In this lesson, I'll be covering how a PC derives its network address using its IP address and subnet mask. I'll begin by taking an IP address, find out the default subnet mask, looking at the first byte of that IP address, apply the bitwise AND concept and extract the network address. Then I will take two examples, and in each of the examples I'll compare two IP addresses to check whether they belong to the same network or not. I will conclude by discussing what is within the network, that is intra-network, and what is across the network, that is inter-network communication. If we are given an IP address 192.168.20.10, let us look at our table that we have learned in the past. Based on the class, a default subnet mask is assigned. In this case, the IP address is 192.168.20.10. It belongs to the class C, and that is why the default subnet mask applicable to this IP address is 255.255.255.0. Next, we have learned this concept of bitwise AND operation applied to decimal numbers. 4 steps. First step, convert the decimal numbers to the equivalent binary number. Then perform the bitwise AND operations between the two binary numbers and get the result. These are step 2 and 3. And finally, in the step 4, convert the result binary number to the equivalent decimal number. This concept I will apply on the IP address byte by byte. Okay, let's go. So, given the IP address and the subnet mask, we will convert both of them into their binary equivalent. And now that I have the binary equivalent, I will apply the bitwise AND. And the three rules are the same. 1 and 1 gives me 1, 1 and 0 gives me 0, and 0 and anything is 0. And get the result. And now that I have the binary result, I will convert it back to the decimal format. And this is what I get. 192.168.20.0. So I can say that 192.168.20.10 IP address belongs to the network 192.168.20.0. Now, having learned the concept of deriving a network address from a given IP address and its subnet mask, let's further utilize this to check whether two IP addresses belong to the same network or different networks. So the first example, I have taken two IP addresses 192.168.20.10 and the second one is 192.168.20.192. Okay. Both of their first octets are 192. That means they both belong to class C and hence both of their default subnet masks will be 255.255.255.0. Convert these into their binary equivalent. Convert the subnet mask also into their binary equivalent. And then apply the bitwise AND and get the result. And finally, convert the binary results into the decimal equivalents. And this is what we get. And if we compare both of them, they both are same. So we can say that the two IP addresses that were given to us belong to the same network 192.168.20.0. Let me take the next example. First IP address is 192.168.72.10 and the second IP address is 192.168.20.192. We'll follow the same steps. Look at the first octet to derive the correct default subnet mask. They both are 192, so the default subnet mask for both of them are same. convert them into their equivalent binary, convert the subnet mask also to equivalent binary, apply the bitwise AND, get the result for both, and then finally convert them to their decimal equivalent. So the first one has given me the network address 192.168.72.0, and the second one has given me the address 192.168.20.0 for the network part. So if we compare them, they both are different. That means these two IP addresses belong to two different networks. So the first one, that is 192.168.72.10, belongs to the network 192.168.72.0, and the second IP address 192.168.20.192 belongs to network 192.168.20.0. Intra-network and inter-network communication. When two PCs that have IP addresses that belong to the same network, they are communicating with each other, that communication is known as within the network communication or intra-network communication. If you have to visualize them, they both PCs belong to the same network 192.168.20.0. Pay attention to their IP addresses 192.168.20.192 and 192.168.20.10. Same network 192.168.20.0. If they have to communicate with each other, they are within the same network and they can communicate with each other using a layer 2 switch. So remember, within network is intra-network communication and the device to use for communication is switch. The IP address 192.168.72.10 belongs to a different network. That network is 192.168.72.0. So PC3 here having IP address 192.168.72.10 belongs to the network 192.168.72.0, which is different from the left network, which is 192.168.20.0. And in case PC2 needs to communicate with PC3, this communication will be across networks from one network to another network, and what we call it as inter-network communication. For this, we will need a router. A router is a new device that we learn now. It operates at the network layer of the OSI model or the layer 3 of the OSI model. But remember, anytime a PC wants to communicate with another PC and these PCs are in two different networks, this is across network communication and what we call it as inter-network communication. This is where we require a layer 3 device or a router. To summarize what we learned in this lesson, if an IP address and a subnet mask are given, we now know how to extract the network address. If two different IP addresses are given, we can find out whether they belong to the same network or two different networks. And finally, we learned what is within the network or intra-network communication and what is across network, that is inter-network communication. For the curious minds who wish to know whether there is a limit to the number of IP addresses that can belong to a network, the answer is yes, and this is where subnet mask again comes into play. How does it work? Is something that I will cover after a couple of lessons. For now, I intend to start with intra-network, that is within the network communication. I will go into encapsulation, packet formation and all that, finish that off and then move from intra-network to inter-network communications.